Hey everybody, Swarsky here. Hope you're having a great day so far. We are on to the last kind of culmination of trig, which is word problems. Now we call them, you'll hear this with angle of elevation, angle of depression. It's just a way to define kind of our orientation. So it's really just trig word problems. So the only step that we're going to take back is that we aren't going to have a diagram. We're going to have to do that based off what we are reading and what we see was given to us, which is usually the toughest piece. So we'll get a little definition of angle of elevation and depression, how those link. A little bit of practice. I'm not going to go through every single one just because it's going to get a little repetitive and that'll make this video very long, and I don't want to do that. So I'll probably do a handful. I'm going to do this last one especially as success, so we'll probably end up doing 3, 2 in there, and then the very last one, and you can get some practice. I do have solutions on the daily doc. Make sure you check that, and away we go. So to start with, here are kind of the two options we have. The easiest one to kind of think of is an angle of elevation. Everything goes from, kind of think of how you look, your eye line, so here, horizontal. Everything starts horizontal. Elevation means I look up to it, which means from horizontal up to that. Sorry, I don't know why it's doing that a little more. Up to where see, it's doing it again. I don't know why. Oh, well. Up to that. And that's what means the angle of elevation. So that one's kind of an obvious one to me when I look at that. Starting from horizontal, think eye line, and I look up to that, and then that would be able to kind of orientate. When I say my angle of elevation we know that we're talking about this space here. Now, angle of depression is kind of the funky one because a lot of people, so let's say we have another person, but they're looking down to our friend and we're trying to wave at him or something like that. Our angle of depression, what the biggest mistake people make is they think that it's this piece. And the angle of depression is same thing as elevation, going from the horizontal line, kind of our eye line, and then it goes down to that. So this is the angle of depression, call that theta. Okay, so if I were to kind of make a more general sketch of it, right? These are both horizontal lines, so these are parallel lines. Angle of depression, angle of elevation. They are the same thing. These are alternate interior angles. They're the same piece, okay? Which means I can draw my my diagram two different ways and have the same thing. But the biggest piece is that we're always going from horizontal to the angle. This is the piece that it is not, okay? No. This is what when they do angle of depression, this is the most common mistake that people make, is doing that piece. But as you can see, it's not starting at horizontal, okay? So we always want to start from the horizontal line and then work our way down. Horizontal line, work our way down for both elevation and depression. But we're going to get a few examples, try it out, and see how we do with that, okay? So let's start out this way. Allie wants to measure the height of a tree. And I apologize again for kind of the silliness of some of these, but we have to try and get the pieces in there and get you visualizing. She walks exactly 100 feet away from the base of the tree and looks up, turns around and looks up. Allie's 5 feet tall. The angle from the ground to the top of the tree is 33 degrees. How tall is the tree? So here's what that means. So here's our tree. Easiest thing to do is draw your piece here to see what's really happening. Allie, here's Allie. Okay. Here's the pieces that we know. We know that from the base of the tree to Allie is 100 feet. Hey, there's the first part. Allie's 5 feet tall. Let's just see what that looks like. So 5. And we know that the angle from the ground to the top of the tree, so right here, from the ground, right, ground to top of the tree is what, 33 degrees. Okay? Now there's one thing that I do not need. I do not actually need that. That would be if I needed similarity and wanted to know like how much her shadow was and blah, 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 blah. But if I'm just looking for the height of the tree, I have enough. I know that she's 100 feet away. I know that from the ground up to that is 33 degrees. Now I have enough. And you say, well, what do I do with that? Now it's trig. Okay. So now based off my diagram, I'm going to say, all right, well, what do I have? Well, I have the opposite and the adjacent. I'm going to use tan. Tan of what? I have the degree measure, 33, and that is equal to x over 100. Now it's just the operational piece. X is on the top. I'm multiplying 100 times tan 33, and I end up with, we'll just round to the nearest tenth. In this case, and we also have our units. 9 feet. That's how tall our tree is. It's as simple as that. The challenge becomes where are the pieces and how do they fit? Because that will obviously change what I have. If I thought the 100 feet was here and not here, well, that would change it to sine, and I'm going to get something totally different. If I thought it was here, this is what I was looking for, and this was the missing piece. That was x, and I'm going to have cosine. So you're going to have a lot of different pieces. You just have to make sure you're setting up the correct part, okay? All right. Oh, let's see. All right, I'm going to give you a chance. Pause the video, read, set up the diagram, solve, see if you can figure out the horizontal distance the rescuers are to this person. All right. So here's the tougher one because the angle of depression gives us a little bit of a challenge. Always does with the visual. Okay. So let's draw the piece that we want, or what we want to do. So let's see. Search for airlifting scene, boating accident. So let's draw our boat poorly. This is, again, I apologize for my poor art. Search and rescue team. The helicopter. Ooh, I can draw a helicopter. You ready? I think my pen's dying. Look at that. Okay. So we've got this, the helicopter. We know a couple things here. We know the helicopter's 24 feet above the water. Right? Ooh, we got to draw water, huh? There we go. Now it looks good. Okay. The angle of depression. Here is the challenge for us. Well, let's get the other part. We know what we're looking for is this horizontal distance. It's that piece. So here's my triangle, right? Whoop, whoop, whoop. Angle of depression. This is not the angle of depression. Okay. The angle of depression is this. Okay. This is the angle of depression. This is the 42 degrees. Again, that's the tougher part. And look what I can do. I still have everything that I need, okay? You're basically drawing a rectangle. So if I were to pull that out, here's what I have. 24, here's my missing piece. Again, that's this and this are the same thing. This and this are the same thing, okay? Or I could even rotate it and say the 42 could go here. So I could use the red or the green triangle, okay? And I know, oh, sorry, I'm messing that up. This isn't 24, this is 42. My numbers are getting mixed up. This is 24. Okay, again, what do I got? Well, from the angle, I have the opposite adjacent. Now, you can see I can do the same thing with this. Opposite adjacent, I'm still using tan. Tangent ends up showing up a lot with word problems. It's kind of a nice piece there. Opposite is 24. This is x. We have to be confident with this piece because I'm going to divide 24 divided by tan 42. That would give me to the nearest tenth is 26.7 or 6.5, doesn't matter, feet. Whoop. If I'm going to the nearest tenth, it's 0.7. Okay. That's the base for it. So you have to understand what you're looking at, and the tougher part is this one, because guess what? If I were to do this at 42, I can still get an answer, but in that case, this is going to be opposite. That'll be adjacent. I'm going to get something different, okay? We want to use the right orientation, which is why we have to pay attention to angle of depression. Realize that you can correspond it to the alternate interior from there. Oh, let's do another angle of depression. Try this one out. See how you do. Good luck. Try it out. All right, friends. Let's see. So we got this lighthouse. Watch these drawing skills. Lighthouse. Here's my lighthouse. Off a craggly rock. Why not? Don't want to get hit. Okay. From a man at the top of the lighthouse to a ship. Ooh, we got to draw a ship now. Another boat. I'm good at boats. Look at this. This is like a old-timey boat. Nailed it. So we got lighthouse keeper. He's up at the top. He's saying, oh, well, I'm looking down at this boat, but my angle of depression. Oh, where am I at? Hold on. The angle of depression from the top of the lighthouse. Lighthouse is 2,800 feet tall. We're going to say the lighthouse goes from this 2,800 feet. That's a tall lighthouse. We'll do that. Otherwise, we'll say it's right at the shoreline. So 2,800 feet tall. But where the heck is my angle of depression? Remember, it is not here. Angle of depression is here. Okay, always goes from a horizontal down. Okay, so that means that 33 degrees could also be here. And I'm looking for distance between the ship and the shore right here. Okay, which means the distance could also be here. 2,800 could be right here. Okay, you have your choice. Again, hey, we have, if I'm going to go from 33 degrees, either one, I'm going to get opposite, adjacent, tangent. It's not always going to be the case, so don't get used to like, well, it's always going to be there. It's not going to do that. But there. X is on the bottom. Divide 2,800 divided by tan 33. And you're going to say to yourself, should it be bigger or smaller? 2,800 should be the smallest side, right? 33 degrees. This would be 57 degrees for this other angle here. Okay, so you should realize that I would probably be, twice as big would probably be a good idea. And it is about that. So my thing here, X ends up being to the nearest 10th, 4311.6 feet. With that one. Okay, most of the issues come from, especially angle depression, where your angle is. Draw your figure, draw your figure, draw your figure. Realize that you're always going from the horizontal line over. Let's just give you one more. I don't like that one. Here we go. I like birds. Let's do birds. Ooh, another angle depression. Try it out. Let's master this one. See what you get. Draw your picture. Find your piece. How far is the bird's flight path before it can land? Okay? All right. It's on a perch. Let's draw a perch. Let's say you're on a building. Here's bird. Tweet, tweet. Terrible bird. I don't know what he's doing. He's going to start flying. There's his beak. Bird. Okay? Bird is flying at a height. Oh, he's already flying. Let me draw this right. I got too excited. He was already going to perch. All right. So let's, we got a perch that he's going to end up on. Here, perch, bird. Maybe I got another shot at drawing a nice bird. Here's his wings. Toot, 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 toot. Oh, gosh, that's a good-looking bird. He's at a height of 62. Here's the ground. 62 feet. Terrible. Okay. And he spots a 13 foot, let's see, spots a 13-foot ledge. Think about this. And is at 18, so here's this angle of depression. He's right here, so it's 18 degrees. How far is the bird's flight path before it can land? So that's a direct path. That's this piece right there. This is what I see. The only other thing I can think of, he spots a 13-foot ledge, is that this is the 13. Poorly worded. I had it in my head, and now I'm torn between two things. This is the one problem about trying to write these out, is that it can be interpreted in a correct way. Is like, all right, well, this could be a ledge, right? At 13, which would be fine. I mean, I could find that because I would just take 62 minus 13 and I could figure out what that is. Or if this is the ledge, then that means that the height here is 13. I'm going to go with this piece. So we have 18 degrees, 13 here. That's sine. So I'm going to go sine of, 18. Opposite's 13, then x. So flip-flop. So 13 divided by sine 18, which would be, my direct distance would be 42.1 feet from a poorly worded question. Ick. Yeah, there's some interpretive decision making right there. But there you go. So if you did it the other way and you did 62 minus 13, what would be what? 60, 50, 49, I think. You just do that, it just means that this would be a bigger distance, but there you go. Let's see. Yeah. We'll let you play around with that one. I'll leave that. So what I'd like you to do is your piece here. Skills is just setting up your trig function. So I would really call that optional if you're really struggling. This is the big one. Okay. I do have solutions online. Hopefully you can get to them. Let me know if you have questions. Give them a shot. Also, this extended, if you feel like you got it, really try that out. See how you do. And I will catch you on the next video. See you later, everybody.